Hello students, welcome everyone. Welcome to your favorite channel Vedantu NCERT Solution. In this channel, you will get a detailed solutions and description of each and every NCERT questions, and it will help you to score more in your boards as well as to understand the concepts very clearly. So in this session, we are going to learn how to solve eighth question of your exercise 1.1. Let us first try to read the question. I write the given data, and always when you're writing the questions, children, please note down the given data. It makes a huge difference so that you don't miss out any of the data given, or you do not write it wrongly directly when you're solving. So let us read the question. Show that the relation R in set A. So set A is given. Set A is given as 1, 2, 3, 4, 5. So we have set A, and the relation R is given as elements A comma B should obey, that is modulus of A minus B should be even, that is modulus of A minus B. What is this modulus of A minus B? It's the difference, modulus of the difference of two elements, that should be even. Now we have a second sub question where they're asking us the elements 1, 3, 5 are related to each other. We need to show that, and elements 2, 4 are related to each other, but these two sets are not related to any other element. We have to prove. That is the second part of the question. Now first, this one given relation, let us try to check whether it is reflexive, symmetric, and transitive. As we have already studied, when will a relation be called as equivalence relation? When is that, children? When a relation is reflexive, symmetric, and transitive, we call the relation to be equivalence relation, right? And you have studied how to check whether the given relation is reflexive, transitive, and symmetric. Now let us try to solve this question. Now reflexive. Just observe, children, for any A comma B which belongs to set A, modulus of A minus B, if it is even. Okay. Now for every A comma A, means you are taking the same elements which belongs to set A, modulus of A minus A will give you 0. That means what? Modulus of A comma A belongs to R. Why, children? Why? Because you are getting 0, which is considered to be even. Yes. So hence A comma A obeys the relation, children. Hence what you write? Hence it is a reflexive relation. It is a reflexive relation. It is a reflexive relation. I hope reflexive part is clear now, because A and A, you take A minus A modulus, it is always 0, and 0 is always considered to be even. So hence it is a reflexive relation. Now let us try to check for symmetric and transitive. Now children, tell me, when do you call a relation to be symmetric? A relation will be called symmetric if A comma B obeys the relation and B comma A also obey the relation, correct? Now for A comma B which belongs to set A, let us take A comma B which belongs to set A, modulus of A minus B is equal to modulus of B minus A, right children? Because modulus of difference will remain same. Hence it is symmetric, and I can write A comma B obeys the relation R and B comma A also obeys the relation R. So it is symmetric. Yes. Now once you know it is symmetric, let us try to check whether this relation is transitive. If it is transitive, children, then you can directly write it is an equivalence relation. Yes or no? Yes. Now consider three elements A comma B comma C, which should belongs to set A. Okay, these elements should belong to set A. Now if A comma B belongs to R, that is modulus of A minus B is even, right children? Then B comma C, if it belongs to R, that means it is obeying the relation R. Here you can write B minus C. Right, children? In that case, A comma C also belongs to R. Why, children? Tell me. Because modulus of A minus B plus modulus of B minus C will always give you even. Correct? So in that case, A comma C also belongs to R. Yes, because this is even. Hence, what do we write, children? We have proved it is transitive, symmetric and reflexive. So hence it is, yes, it is transitive. So it can also be called, since R is reflexive, yes, it is reflexive, symmetric, it is symmetric, right, children? Because we know modulus of difference will give you the same value, A minus B and B minus A, and transitive. Hence, it is an equivalence relation. Equivalence relation. Yes, so it is an equivalence relation. Now, just try to understand the second sub question. This is clear. I hope my children have understood this, because it is reflexive, symmetric and transitive. So it is an equivalence relation. Now, show that all the elements of set 1, 3, 5 are related to each other. Now take the set, children. Set 1, 3, 5. Do you notice that all elements, that is all elements, are odd numbers, children? Are odd in the given set. Yes, in this set all numbers are odd. Hence, modulus of A minus B is even for every A comma B from this set. A comma B, for every A comma B which belongs to set A, right? Hence, what you can write? It is an equivalence relation, right, children? No doubt about that. Similarly, one more set what is given is 2, 4. Here, if I'm writing, just observe all elements are even. So, modulus of A minus B is even for every A comma B belongs to R. Yes, belongs to the set A as well as R. Yes, children, here let us write set A for every A comma B which belongs to set A. Now tell me, is there a relationship between set A and set B? Let us consider this as set A or this as set A dash. Let us take this as A dash. Okay. Observe, since element in set A, just observe this, children, very important. Elements of set A are all odd. Element of set A dash are all even. When you take modulus of the difference, you will always get an odd number, not an even number. Hence, each and every element of set A is not at all related to each and every element of set B. So what we can write here? Yes, you can write all elements of set 2, 4 are related to each other. All elements of set 1, 3, 5 are related to each other. You can write the statement again at the end. Okay. This statement has to be written at the end again. And you have to write a statement, since elements in set A are all odd numbers and element in set B are all even numbers. Hence, no element of set A and A dash are related to any element of these two sets. Yes, children? Yes, you need to write this statement, and we have proved the given relation is reflexive, symmetric and transitive. Hence, it is an equivalence relation. And 1, 3, 5. Here all elements are related to each other because all are odd. In the set 2, 4, both the numbers are related to each other because both are even. But a set containing even and odd will not satisfy this relation. Hence, they are not related to any element. I hope you have understood these questions. Please do write and practice. and like, share and subscribe. Share it with your friends so that all of your friends also are able to solve these questions and score more in your board exams. Thank you, students.